Welcome to Get Your FRQ On. This question is from 2006, it's question 3, and it is calculator active. In the question stem, we're given the graph of a function f of x, which consists of a bunch of different line segments, and we define a new function g of x to be the integral from 0 to x of f of t dt. In part A of the question, we are asked to determine g of 4, g prime of 4, and g double prime of 4. All right, by definition, g of 4 is just the definite integral from 0 to 4 of f of t dt. We can get that from the graph. The integral from 0 to 4 of f of t dt would just be the area, the bounded area between the curve and the x-axis of f of t, and that turns out to be 3. By the fundamental theorem of calculus, g prime of 4 is f of x, or g prime of x is f of x, so g prime of 4 would just be f of 4, which we can also get from the graph. F of 4 is 0. And also by the fundamental theorem of calculus, g prime, if g prime of x is f of x, g double prime of x would be f prime of x. So g prime of 4, or g double prime of 4, would just be the value of the derivative of f at 4, which turns out to be negative 2. In part B of the question, we are asked if g of x has a relative minimum, relative maximum, or neither at x equals 1. Now, since g prime of x is f of x, g of x could have a relative extrema at x equals 1 if g prime of 1 equals 0 and changes sign at x equals 1, or if g prime of x is undefined at x equals 1, but still changes sign there. Since g prime of x is f of x, then f of 1 is 0. Well, if f of 1 is 0, and f of x changes from negative to positive, g of x would have a relative minimum at x equals 1. Well, we have a graph for f. We can just check this information. All right? So, in fact, this graph does demonstrate that f of 1 is equal to 0, and f of x changes from negative to positive at x equals 1. All right, so if it changes from negative to positive, it should have a relative minimum at x equals 1. In part C of this question, we are given that f is periodic with period 5. We're also given that g of 5 is equal to 2, and we are asked to find g of 10 and the tangent line to this graph at x equals 108. Well, since f is periodic with period 5, we know that f of 0 and f of 5 and f of 10 have the same function value. All right, this implies that g of 5 is the integral from 0 to 5 of f of x dx, which is 2, and that g of 10 is the integral from 0 to 5 of f of x dx plus the integral from 5 to 10 of f of x dx, which would just be two different integrals whose value is 2, so that is 4. So g of 10 is 4. The tricky part is trying to figure out what the tangent line would be at x equals 108. But since this is a periodic function, really one of the things we have to consider is how many periods are exhausted as we go from 0 to 108. All right, so g of 108, by definition, would be the integral from 0 to 108 of f of x dx, which would be 2 times whatever 105 divided by 5 is, because that fraction gives me the total number of complete periods before I get to 108, since 108 is not divisible by 5. And then I just have to tack on the integral from 105 to 108 of f of x dx. All right, so I get 42 plus 2, which is 44. All right, so now I know I'm interested in x equals 108. The value of g of 108 is 44. And g prime of 108 is just f of 108, which should be the same as f of whatever 105 plus 3 is. All right, well, given the fact that this is a periodic function, f of 108 would just be the same as whatever f of 3 is, which is 2. So now I have all the information I need to write the tangent line to the graph of g at x equals 108. All right, the tangent line at x equals 108 has equation y minus 44 equals 2 times x minus 108.